All right, let's get right into it. Welcome everyone to this Project SIP9 Explainer. Today, I want you to think of our time together not just as your typical math lesson, but as a full-blown math detective mission. We're going to solve the case of the four-sided shapes. We'll start with the absolute basics, build up our evidence step by step, and by the end of this, you are going to have the exact tools you need to decode some of the trickiest shapes in geometry. If you've ever looked at a shape and felt kind of overwhelmed by the math hiding behind it, don't sweat it. We're going to break this down so completely that it literally becomes second nature.
So here's the 5-step staircase we'll be climbing today. We've got 1. Intro and the core rule. 2. Classifying our shapes. 3. Parallelogram properties. 4. The algebraic challenge. And wrapping up with 5. Next steps.
Let's kick things off with Phase 1, Introduction and the core rule.
Our golden rule today revolves around the quadrilateral. Now that's a long word, but it just means any closed two-dimensional geometric figure made up of exactly 4 straight sides, joined at exactly 4 corners, which we call vertices in math speak, and containing 4 interior angles. That right there is the fundamental DNA of these shapes. And you know what's really cool about this? It describes things you're already incredibly familiar with. These geometric suspects are literally everywhere. Think about the windows in your room, the books sitting on your desk, or even just the surface of your table. They're all built on this exact same structural foundation.
Now, mathematicians love a good shortcut, and here's a brilliant one for you. Instead of writing out that massive word quadrilateral every single time, we use a simple symbol that looks like a little tiny rectangle. So if you see a shape labeled with 4 letters, say TEAL, you might just see it written as this little box followed by TEAL. We just read that aloud as quadrilateral teal. It saves us so much time and keeps our notes looking perfectly clean.
Moving right along to Phase 2. Classifying our shapes.
So, how do we sort our geometric suspects? Well, we do it systematically by simply counting the number of parallel sides they possess. Parallel lines, just as a quick reminder, are lines that will never ever intersect, no matter how far you draw them out. Now, if our shape has 2 pairs of parallel sides, boom, it's a parallelogram. If it has exactly 1 pair of parallel sides, we call it a trapezoid. And if it has absolutely 0 parallel sides, that is a trapezium. The big takeaway here is that just by checking for those parallel lines, you can instantly sort any 4-sided shape into one of these 3 main buckets. Let's zoom in on the most famous bucket, the parallelogram family. These shapes all share those 2 pairs of parallel sides, but they each have their own special characteristics. A rectangle, for instance, is a parallelogram with 4 perfect right angles. A rhombus is a parallelogram where all 4 sides are perfectly equal, or congruent. But then, consider the square. A square requires 4 congruent sides and 4 right angles. This basically means a square acts as the ultimate disguise. It's technically a special type of rectangle, and it's also a special type of rhombus because it magically satisfies the rules for both.
Now, let's compare 2 highly unique shapes that totally break the standard parallelogram mold. Take the kite, for example. Instead of opposite sides being equal, a kite has 2 pairs of adjacent sides, meaning the sides right next to each other, that are congruent. Then contrast that with the isosceles trapezoid. It has its 1 pair of parallel sides, sure, but the slanted non-parallel sides, which we call the legs, are exactly the same length. Comparing their specific side lengths like this makes it so easy to see exactly what defines them.
All right, detectives, it is time for your very first field test. I want you to pause this explainer right here, open up your Google form, and tackle checkpoints 1 and 2, where you'll identify the quadrilaterals we just talked about. Go ahead, hit pause, lock in those answers, and press play when you're ready to step up to the next level.
Welcome back. Let's dive right into Phase 3, Parallelogram Properties Explained.
These next 4 rules, they are the absolute keys to unlocking this whole mystery. If a shape is a parallelogram, these rules are strictly non-negotiable. First, the opposite sides are both parallel and equal in length, meaning they're congruent. Second, the opposite angles across from each other are also perfectly equal. Third, the consecutive angles, the ones sitting right next to each other, are supplementary, which means they add up to exactly 180 degrees. And fourth, if you draw lines connecting the opposite corners, those diagonals will perfectly cut each other in half. They bisect each other.
Okay, pay close attention here because this is literally the #1 trap students fall into. You absolutely must know the difference between opposite and consecutive angles. First up, opposite angles. Since they're across from each other, they're non-adjacent. Their rule? They are always equal. But then you have consecutive angles. These are adjacent. They actually share a side. Their rule?
They're supplementary, meaning they add up to 180 degrees. Seriously, do not mix these two up, and you'll save yourself so many headaches down the line.
Before we move on, let's quickly nail down 2 essential structural terms you'll want in your math tool belt. A vertex is simply the corner point where 2 lines meet, and the height is the strictly perpendicular distance between the top base and the bottom base of the parallelogram. It's kind of like measuring how tall a building is, straight up and down, never slanted. Knowing exactly where the vertices are and accurately identifying that height are vital clues for the calculations we're about to do.
All right, time for our second interactive pause. Using those distinct parallelogram rules we just mapped out, I want you to conquer checkpoints 3, 4, and 5 on your Google form. Read the questions carefully, ask yourself which specific property applies, select your answer, and I'll be right here waiting for you when you get back.
Awesome job. Now for Phase 4, the algebraic challenge.
I know, algebraic challenge sounds like the boss level, right? But honestly, it's incredibly straightforward. We're just taking those visual geometry rules we just learned and translating them into the language of math. Step 1, identify the geometric property visually. Look at the shape and ask, are these sides opposite each other, or are these angles next to each other? Step 2, set up the algebraic equation based on that exact rule. And step 3, compute cleanly, using your basic algebra skills to isolate and solve for that missing variable, which is usually x. If you get the visual rule down in step 1, the algebra in steps 2 and 3 becomes totally automatic.
So, what does that translation actually look like in practice? Well, let's look at our 2 most common rules. Say a problem gives you algebraic expressions for 2 opposite sides. Because you know the rule that opposite sides are equal, you literally just put an equal sign between them. Side 1 equals side 2. What if they give you expressions for 2 consecutive angles? You know the rule is that they add up to 180, so you just write it out. Angle 1 plus angle 2 equals 180 degrees. See? You're literally just turning geometry rules into algebra sentences.
And now it's time to prove it. This is your final interactive pause. I want you to tackle the hardest checkpoints on your form, checkpoint 6, 7, 8, and 9. Use our 3-step method. Identify the property, set up the equation just like we showed, and compute cleanly to calculate those unknown values. Pause the explainer, trust the process, and hit play when you've cracked the case.
And finally, Phase 5, next steps.
Welcome back, and huge congratulations on making it to the final phase. Seriously, I really want to celebrate your incredible perseverance today. You just climbed that entire staircase, moving all the way from identifying basic visual rules to solving complex algebra based on geometric properties. That is a massive achievement in logical thinking. And because you followed the structured path so well, you are completely ready for the final step. I want you to scroll right down in your Google form to complete the final independent practice, which covers questions 10 through 18. Take your time, lean on the rules you just mastered, and always verify your algebraic solutions against those geometric properties we discussed. Before we completely wrap up this explainer, I want to leave you with one final thought. Look around you right now. Take a second. How many perfect parallelograms are hiding in plain sight in your room? Now that you know the hidden rules of right angles, congruent sides, and parallel lines, I promise you'll never look at the physical structures around you the same way again. The world is built on geometry, and now you hold the key to understanding it. Great work today, math detectives. Best of luck on your independent practice, and I'll catch you next time.